Breaking news for Tesla fans and tech enthusiasts. The production line for the Tesla PiPhone 2026 has officially started. But what does this mean for drivers and everyday tech users? How soon could you actually get your hands on one? And will it finally make interacting with your Tesla seamless and smarter than ever? Today, we'll reveal the key details Elon Musk hasn't shared publicly yet. From production capacity and rollout timelines to the features that could challenge Apple and Samsung, we'll break down what matters most for your daily life behind the wheel and on the go. Let's find out in today's episode. Before we jump in, hit subscribe and ring the bell. Let's help AutoGearshift cross that oddly satisfying 20,000 subscriber mark. This is the most complete breakdown of the PiPhone Fold we've done so far. Some things may sound familiar, but the critical pieces you haven't heard? They're all right here. Stay with me. It all comes together in this video. How fast can the Tesla PiPhone 2026 actually hit the market? With Tesla officially flipping the switch on its PiPhone 2026 production line, the immediate question for fans and tech-savvy drivers is simple yet critical. How soon will this device actually land in consumers' hands? According to insiders familiar with the Fremont factory, Tesla is ramping up production to approximately 120,000 units per month in the early stages. To put this into perspective, Apple's iPhone 17 rollout in its first month reached around 90,000 units, meaning Tesla is already planning a faster production pace despite being new to the smartphone market. This aggressive target signals the company's commitment to not only compete, but to dominate the niche of EV-integrated devices. Production speed alone doesn't guarantee success. Tesla is reportedly leveraging a highly automated assembly line equipped with advanced AI-driven robotics, which drastically reduces human error and increases overall efficiency. Analysts estimate that this setup could improve throughput by around 25% compared to conventional smartphone assembly lines. For consumers, this translates to fewer shipping delays, a reduced likelihood of defective units, and faster delivery of software updates that directly integrate with Tesla vehicles. In practical terms, it means an owner who pre-orders a PiPhone could see their device in weeks rather than months, a stark contrast to typical foldable phone launches that often face multi-month back orders. Supply chain dynamics will also play a crucial role in availability. Tesla has opted for a hybrid sourcing model. Key components, including high-density battery cells and proprietary Tesla AI chips, are produced in-house, while secondary elements like foldable OLED panels are sourced from South Korea and Taiwan. This approach allows Tesla to maintain quality control on the most critical parts, mitigate risks from external shortages, and adjust production more flexibly than competitors relying entirely on third-party suppliers. Experts project that this model could enable Tesla to reach 350,000 units globally in the first quarter, which would surpass early shipments for Apple's rumored iPhone Fold 2026 and set a new benchmark for EV-connected consumer devices. Price also plays a decisive role in adoption speed. While Tesla has not officially confirmed numbers, insider sources point to a target price around $219, undercutting premium foldable models from Apple and Samsung by a significant margin. More than just affordability, the PiPhone's pricing strategy emphasizes value for use, as it integrates seamlessly with Tesla vehicles to provide real-time diagnostics, energy management insights, and AI-assisted driving features. For Tesla owners, this transforms the PiPhone from a simple communication device into a functional tool that enhances daily driving and vehicle management. Ultimately, the combination of rapid production capabilities, advanced automation, hybrid supply chain sourcing, and highly targeted functionality could make the PiPhone 2026 one of the fastest adopted devices in automotive tech history. Compared with prior foldable phones, which often face logistical bottlenecks and delayed software rollouts, Tesla's approach suggests that drivers and tech enthusiasts may see units in their hands far sooner than expected. How fast do you think Tesla's PiPhone 2026 production line will deliver units? Fast or slow? Comment fast if you believe the factory will pump out devices quickly, or slow if you think it will take longer, and share your reason in the comments below. How much will Tesla PiPhone 2026 cost, and is it worth it? Tesla's decision to price the PiPhone 2026 at just $219 is one of the most surprising moves in the smartphone market this year. At first glance, it is a fraction of the cost of Apple's iPhone 17 Fold, expected at $1,799, and Samsung's Galaxy Z Fold 5 at $1,749. On paper, the price might make readers wonder how Tesla can deliver a foldable phone integrated with AI and car functionality for so little, but a closer look reveals a carefully calculated strategy. By setting the PiPhone at this level, Tesla positions it not as a premium luxury device, but as a practical tool for every Tesla driver, ensuring mass adoption and deep integration into its ecosystem. For Tesla owners, the value goes far beyond the $219 price tag. The PiPhone is designed to connect seamlessly with vehicles, providing real-time battery monitoring, climate control adjustments, predictive maintenance alerts, and AI-assisted driving features. Replicating this experience on an iPhone or Galaxy Fold would require multiple third-party apps, additional hardware, or subscription services, likely costing users $200 to $300 per year. In effect, the PiPhone pays for itself within the first year, offering a level of return on investment unmatched by any foldable smartphone currently on the market. Psychologically, the $219 price is compelling. It is low enough to feel accessible, even impulsive, yet paired with Tesla's brand and the real-world utility it provides, the perceived value skyrockets. Consumers feel they are getting premium technology and integration at a fraction of the cost of Apple or Samsung foldables, making it far more likely that early adopters will jump in immediately. The low price also serves a long-term strategic purpose. By making the PiPhone affordable, Tesla can seed a broad user base for future software enhancements and subscription services, such as advanced AI driving features or cloud-based vehicle analytics. These incremental upgrades, priced around $10 to $15 per month, could generate recurring revenue while keeping the initial device accessible. Early adopters gain both the immediate benefit of Tesla integration and the potential advantage of exclusive access to new features, creating loyalty and engagement that could last for years. In terms of market impact, pricing at $219 allows Tesla to reach a much wider audience than premium foldables. With initial production targeting 350,000 units in the first quarter and prioritizing the US, Canada, and parts of Europe, Tesla could deliver more devices faster than Apple or Samsung, whose high-priced foldables often face initial supply constraints. Early buyers benefit from rapid access to Tesla-specific functionalities, while later buyers will experience a stronger incentive to adopt to keep up with ecosystem advantages. Compared with Apple and Samsung, the PiPhone at $219 offers unparalleled value. While a foldable iPhone or Galaxy requires substantial additional spending to achieve similar Tesla vehicle integration, the PiPhone bundles these capabilities into a single affordable device. For drivers who rely on Tesla technology daily, it is not just a phone. It is a tool that enhances efficiency, saves time, and reduces reliance on expensive aftermarket solutions. What makes Tesla PiPhone 2026 stand out from Apple and Samsung? Early reports suggest the PiPhone will feature a proprietary AI chip capable of processing real-time vehicle data, meaning you could receive alerts about battery health, tire pressure, or even predictive maintenance right on your phone. For comparison, Apple's iPhone 17 requires third-party apps to display similar car metrics, and the data refresh rate can lag by up to 5 seconds, something Tesla claims its PiPhone reduces to under 1 second. Battery technology is another major talking point. The PiPhone reportedly uses a miniature version of Tesla's next-gen aluminum-ion battery, which could provide up to 60% faster charging than conventional lithium-ion batteries found in comparable devices. users could potentially charge the phone from 0 to 80% in just 25 minutes, while traditional foldable smartphones from Samsung and Apple take 45 to 50 minutes under similar conditions. The display is equally ambitious. Sources indicate a foldable OLED panel spanning 7.2 inches when fully open, offering ultra-smooth 144 Hz refresh rates. While Samsung's Galaxy Fold 5 reaches 120 Hz, Tesla's emphasis is on real-time integration with car navigation and dashboard apps. Imagine checking your Tesla's energy consumption graph while unfolding your phone to a tablet-sized interface in a single motion. This isn't just convenience. It's functionality designed specifically for EV drivers. Connectivity is where Tesla may really have the edge. The Pi phone will reportedly support a private mesh network with your Tesla, enabling features like encrypted over-the-air updates, remote climate control, and vehicle location tracking without relying solely on cellular data. This could appeal particularly to drivers living in rural or low-signal areas, where traditional smartphones often struggle to maintain consistent connection to their cars. Finally, Tesla insiders hint at a modular approach for software updates. Unlike Apple or Samsung, which require major OS updates every year or two, the Pi phone could receive incremental upgrades monthly, directly enhancing car-related functionalities. For everyday drivers, this means continuous improvement without the need to buy a new device, a cost and time saver that could resonate strongly with tech-savvy Tesla owners. Are you excited about the foldable display, faster charging, and real-time car integration? Or do you think Apple and Samsung still have the edge? Drop your thoughts in the comments below. We want to hear how you'd use the Pi phone in your daily driving routine. The iPhone used to be loved for bringing back large screens that made watching movies, reading news, and working much easier. But in recent years, that longer and longer screen has become a hassle. Hard to fit in shirt or pants pockets, easy to drop, and almost impossible to use comfortably with one hand. The 2026 Tesla Pi phone, a vertical foldable phone, steps in as a more practical answer for real life. These are the features that matter when you actually live with the device. Zero crease spine. While the iPhone 17 Pro Max is still a single slab of glass that only has two states with the screen on or off, the Tesla Pi phone is designed with a vertical folding mechanism that bends 180 degrees with almost no crease. The difference comes from the zero crease spine system that distributes folding force across multiple small joints, similar to a chain. When the Tesla Pi phone is opened, the entire surface is pulled flat with no sunken center. Thanks to this structure, the Tesla Pi phone display can bend with a radius of only about 2 to 3 millimeters, and then return to a flat state like a mini tablet. This is something a design not made to bend, like the iPhone, can hardly achieve because the entire glass surface of the iPhone 17 Pro Max is optimized only for flat impact resistance rather than folding. More importantly, the display area of the Tesla Pi phone when opened is about 40% larger than the traditional 6.7-inch screen of the iPhone 17 Pro Max. The entire display maintains uniform brightness and color without dark or discolored areas at the fold, unlike many foldable models that viewers may have seen. Finally, the opened body forms a more square surface that expands both horizontally and vertically, so even when users increase text size for easier reading, they still keep many lines of content on the screen. What's the biggest benefit of the zero crease spine for you? A. Opens flat with no crease. B. Smoother viewing across the fold. C. Increased display area. Comment your pick below. Compact mode. Continuing from the open display, compact mode shows the other side of Tesla Pi phone's design philosophy. When folded, all hardware power is packed into a small, thick, and solid body. In its folded state, the Tesla Pi phone measures about 132 millimeters tall, 68 millimeters wide, and 11 millimeters thick, noticeably shorter than the approximately 161 millimeter candy bar body of the iPhone 17 Pro Max. This difference in height creates a clear advantage when placing the phone in a pocket, The Tesla Pi phone fits fully inside without sticking out and does not press hard into the thigh when sitting. This makes it more suitable for carrying all day, especially for people who move frequently. Not only is it more compact, but the exterior surface of the Tesla Pi phone is also designed carefully. The back has a matte finish with a high friction coefficient combined with a strong metal frame. So when the phone is placed in a smooth fabric pocket, it grips firmly. It is less likely to slip out compared to a smooth glass back and long body phone, which is a common issue for iPhone 17 Pro Max users when pockets are slightly loose or made of smooth fabric. Cybertruck-grade titanium alloy hinge. Folding every day raises the question of whether the hinge can withstand it. Tesla Pi phone uses a titanium alloy hinge module similar to materials on Cybertruck, built from many small joints that evenly distribute force. In testing, this structure endures 300,000 folds with looseness increasing by less than 5%. So if you fold and unfold 150 times per day, it would take over 5 years before the feel of opening and closing changes. The hinge of the Tesla Pi phone keeps both halves aligned. It does not sag when opened or wobble when folded. Even when you tap the screen firmly, the phone stays stable, feeling close to a solid unibody device even though it can fold. The iPhone 17 Pro Max never faces this challenge because it does not fold. But that also means it cannot offer the flexible, expandable, and compact experience Tesla Pi phone provides. In daily use, after 5 to 7 years, the Tesla Pi phone can open smoothly without noise or play in the hinge. A foldable whose hinge remains tight, crease does not sag, and frame stays straight will hold resale value, and buyers can judge its condition after just a few folds. Self-healing polymer layer. The next advantage Tesla Pi phone has over the iPhone 17 Pro Max comes from the screen surface itself. Instead of hard glass, Tesla Pi phone uses a flexible OLED panel topped with a transparent impact-resistant polymer layer and an outer self-healing polymer layer that can repair light scratches. When scratched lightly by keys or dust in a pocket, the molecular chains in this polymer rearrange under temperature and gentle pressure, so small marks fade in about 60 to 120 seconds. In drop tests where the device falls on its edges from 1.5 meters onto steel, Tesla Pi phone keeps over 90% of screens intact, while traditional glass screens stay around 20%. Thanks to this elastic surface that absorbs impact, the Tesla Pi phone is roughly 7 times more resistant to cracking than regular tempered glass. In daily use, the higher friction polymer surface makes the Tesla Pi phone slide less on inclined surfaces or car dashboards, and the elastic outer layer absorbs force before it reaches the display panel. Because the screen stays clear longer and breaks far less often, users avoid several $100s in potential display repairs over 4 to 5 years, making Tesla Pi phone noticeably cheaper to own than an iPhone 17 Pro Max, especially for average income users. Split View Vertical Productivity Mode. On large screen phones like the iPhone 17 Pro Max, power is abundant, but multitasking is still awkward. The long, narrow screen makes split view cramped, so users keep switching between apps instead of using them side by side. Tesla Pi phone is built to fix this, with Split View Vertical Productivity Mode that fully uses the vertical fold when opened. When activated, the Tesla Pi phone divides the display into 2 clear zones. The upper area, about 60% of the screen, is ideal for maps, documents, emails, or spreadsheets. The lower 40% is for messages, notes, quick replies, or Spotify. Thanks to the almost square ratio when opened, each half stays wide and readable, instead of feeling squeezed like when you try 2 apps on the tall, narrow screen of the iPhone 17 Pro Max. Both apps on Tesla Pi phone run smoothly side by side, and scrolling or dragging maps remains stable. Fold-optimized dual-pack battery. Most large screen phones like the iPhone 17 Pro Max need overnight charging because their batteries under 4,000 mAh only deliver about 24 to 36 hours of mixed use. Tesla Pi phone is built to break that pattern. Inside the Tesla Pi phone is a fold-optimized dual pack with two separate batteries, each around 6,000 mAh, mounted in each half of the device. The total capacity reaches roughly 12,000 mAh, about 3 times higher than the iPhone, and the power management system shifts load depending on whether the phone is open or folded. With both packs working together, Tesla Pi phone can provide 5 to 6 days of mixed use, with around 30 to 40 hours of screen-on time. When used mainly for calls, messaging, email, and light news, it can stretch past 14 days on a single charge. Even with heavy tasks like maps, music streaming, and split-view mode for hours a day, the Tesla Pi phone still lasts about 3 to 4 days. The fold-optimized dual pack is also designed for longevity, offering roughly 1,500 charge cycles before capacity drops to around 80%, compared with about 800 cycles on many single-battery phones. Dual-angle fold-cam camera system. The Tesla Pi phone does not chase extra lenses. It uses the folding body to create the dual-angle fold-cam system that the iPhone 17 Pro Max simply cannot match. The main camera sits in a rounded pill-shaped module with a 50-megapixel sensor around 1 over 1.3 inch in size, f1.8 aperture, and a 23mm wide lens, next to a 12-megapixel ultra-wide camera. When the phone is folded to about 90 to 120 degrees, Tesla Pi phone switches into half-fold mode, with the lower half as a base and the upper half as screen and camera. The device can stand firmly on a table, shelf, car hood, or window ledge with no external tripod, acting as a built-in mini tripod with tilt from roughly 60 to 150 degrees relative to the surface. In this mode, users can shoot hands-free interviews, vlogs, live streams, or FaceTime calls. Dual-angle fold cam supports angle locking in 10-degree steps, making it easy to fine-tune framing to match subject height or phone placement. At night, this stability allows longer shutter speeds, for example from 1/30th to about 1/8 of a second, combined with optical stabilization on the main sensor for brighter, less blurry footage. For family videos or DIY tutorials in garages, workshops, or dim construction sites, Tesla Pi phone is ready on its own, while an iPhone 17 Pro Max almost always needs an external tripod or mount to do the same. Among the 7 features listed above, which detail do you think is the most valuable for the Tesla Pi phone's foldable ability? Select the numbers and share your thoughts with us. New leaks coming out this week have shaken up the tech community, pointing to what may be Tesla's most aggressive move into consumer electronics yet: the rumored Tesla Pi phone Fold 2026. Multiple supply chain sources and early engineering reports suggest that Tesla is preparing a foldable device built around battery endurance, satellite connectivity, and rugged mobility, areas where Apple's upcoming iPhone 17 Pro Max is still playing catch-up. So here are 3 more features to help you judge whether the Pi phone actually makes sense. How is Tesla building a foldable phone with EV-grade battery life that beats the iPhone 17 Pro Max? According to the latest engineering leaks analyzed by several battery specialists, the strongest advantage Tesla may bring to the Pi phone Fold is its rumored EV-derived battery system. While Apple is expected to push the iPhone 17 Pro Max toward a higher density cell, some analysts predict a modest jump to around a 4,900 to 5,000 mAh pack. Tesla appears to be testing a compact, energy-dense module inspired by the company's 4680 cylindrical chemistry. Early reports describe a folded format battery with an estimated 6,500 to 7,000 mAh capacity, built with the same silicon-enhanced anode structure used in Tesla's mid-tier pack upgrades. If accurate, this would give the Pi phone Fold not just more hours on paper, but extended screen-on time that specialists estimate could reach nearly 18 hours of mixed usage. More interestingly, some insiders claim Tesla is pushing for a 70 to 80-minute full recharge, using a modified 65 to 70-watt charging controller. While Apple is projected to keep its charging speed conservative, Most leaks point to the 17 Pro Max staying near the current 27-watt ceiling. The Pi Phone Fold could realistically hit 50% battery in under 20 minutes, rivaling top-tier Android flagships. For viewers who constantly move between job sites, road trips, and vehicle integration, this difference is not theoretical. It means plugging in before a drive and having a fully operational device for navigation, remote vehicle control, and media without worrying about midday battery anxiety. But what's grabbing even more attention from EV analysts is Tesla's rumored thermal stability layer. Instead of adding more graphite padding like traditional phones, Tesla is said to be experimenting with a thin heat spreader, similar to that used on the Model Y heat pump system, designed to keep the battery within a stable 25 to 32 degrees Celsius window during heavy load. If this proves true, the Pi Phone Fold would be one of the first smartphones that can maintain peak performance for extended periods, useful for gaming, 4K recording, and even Starlink-linked video calls in remote zones. Meanwhile, most foldables today throttle within minutes because of heat buildup in the hinge area. This is where Tesla's automotive background makes a measurable difference. Thermal engineering is already their specialty. How could Tesla's satellite system deliver the one feature Apple still won't touch? One of the most persistent leaks surrounding the Pi Phone Fold 2026 is its rumored integration with a scaled-down Starlink module, something experts have been dissecting ever since early PCB schematics circulated through supply chain trackers last quarter. While Apple is expected to expand its emergency satellite messaging on the iPhone 17 Pro Max, analysts widely agree it will remain limited to low-bandwidth SOS functions. Tesla, on the other hand, appears to be aiming for a much broader communication range. Reports suggest a compact 18 to 22 mm antenna array housed near the upper hinge of the foldable frame, capable of linking to a low-orbit Starlink micro node with a sustained downlink estimated between 24 and 35 megabits per second. Even at the low end of that range, it would surpass current smartphone satellite systems by multiples, enabling not just emergency contact, but full message syncing, navigation updates, low-res video calling, and possibly even compressed media pulling in areas where cellular towers completely fail. For users who regularly take long drives, explore rural highways, or work in construction sites far outside urban networks, this is not a small advantage. A phone that remains fully connected, even where your truck's dashboard signal drops to zero, changes the way you handle navigation, fleet management, or basic communication. Many analysts point out that Tesla already operates more than 6,000 active Starlink satellites. Even assigning a tiny fraction of that network to mobile devices would give Tesla an infrastructure advantage no other smartphone maker can replicate without negotiating with third-party providers. Apple, meanwhile, is still dependent on Globalstar partnerships, with limited global coverage and no promise of expanding to general-purpose satellite internet by 2026. The engineering challenge, however, remains the antenna and power draw. Some early teardown analysts estimate that a Starlink micromodule running at moderate activity could consume 2.5 to 3.1 watt-hours during transmission. High, but manageable, with a 6,500-plus milliamp-hour battery like the one rumored for the Pi Phone Fold. That's precisely why experts believe Tesla is even exploring this feature. Their battery overhead gives them the room to support such real-time connectivity. Heat dissipation is another concern, yet some leaked prototypes reportedly show a thin graphite vapor chamber stretching across the foldable's mid-spine, helping the device maintain stability even during satellite handshakes. If this design is accurate, it would allow the Pi Phone Fold to perform sustained satellite communication without thermal throttling, something current devices can't do without aggressive downscaling. The iPhone 17 Pro Max is expected to excel in camera upgrades and processor efficiency, yet it is unlikely to offer a communication feature this transformative. For tech users who depend on reliability in unpredictable environments, truck owners, frequent travelers, off-grid explorers, or anyone driving long distances, the advantage is clear. Tesla turns the Pi phone fold into a communication device engineered for movement, not just entertainment. How will Tesla's rugged foldable and vehicle integration create a category Apple can't compete in? The third feature rumored for the Tesla Pi phone fold 2026, and the one analysts say might be its most disruptive, is its reinforced folding chassis paired with deep vehicle integration. According to multiple supply chain leaks, Tesla is testing a dual-rail hinge system machined from a lightweight alloy similar to the aluminum used in the Model 3's crash structure components. Early material reports describe tensile strength measurements in the 380 to 420 megapascals range, significantly higher than the 250 to 300 megapascals alloys typically found in current foldable phones. If these numbers hold, the Pi phone fold could withstand drops, vibration, and hinge stress far beyond the durability standards of today's consumer foldables, which often fail after 200,000 to 250,000 folds. Several teardown engineers predict Tesla may target a cycle rating closer to 350,000 folds, roughly equivalent to opening the phone 150 times a day for more than 6 years. For people who work outdoors, travel frequently, or treat their gear like an extension of their vehicle, this type of structural integrity is more valuable than cosmetic materials. And this conversation is becoming even more relevant as Apple is reportedly preparing its own first-generation iPhone Fold for release next year. But analysts warn that Apple's debut foldable is likely to follow a slimmer, more luxury-oriented design philosophy, similar to the iPhone Pro line, rather than the rugged, tool-grade approach rumored for Tesla. That means durability benchmarks may land closer to mainstream foldables than the vehicle-inspired materials Tesla is experimenting with. In other words, even with Apple entering the foldable race, the two companies may still be targeting completely different user segments. What makes the Tesla rumor even more compelling is how the Pi phone fold is reportedly designed to link with Tesla vehicles at a system level. While Apple aims to deepen CarPlay integration in the iPhone 17 Pro Max and may extend some of those features to the upcoming iPhone Fold, the Pi phone fold is expected to function more like a native Tesla component. Insiders claim Tesla is preparing an ultra-low latency Bluetooth and UWB hybrid connection that would reduce phone-to-vehicle command time to under 90 milliseconds, nearly half the latency of current smartphone key systems. That would allow the Pi phone fold to serve as a seamless digital key, remote climate controller, security monitor, and even an interface for upcoming maintenance diagnostics. Some software watchers believe Tesla might go further, enabling direct syncing with FSD navigation routes, so drivers can plan complex multi-stop journeys on the phone and push them instantly to the vehicle. Apple's CarPlay 2.0 is evolving, and the iPhone Fold will likely support it, yet it still remains an overlay. Tesla's rumored system sounds like direct integration with the car's core software. Add to this the leaks about a sunlight-readable secondary display measuring around 2.4 to 2.7 inches on the outer shell, specifically tuned for vehicle functions, and the Pi phone fold starts looking less like a foldable smartphone and more like a multifunction control terminal for Tesla owners. This direction makes strategic sense. While Apple competes primarily in consumer tech luxury, Tesla is positioning the Pi phone fold as a tool built for mobility, durability, and total ecosystem control, much like how the company designed the Model Y to dominate practical segments instead of chasing design awards. Analysts argue that even with the iPhone Fold entering the market, Apple still cannot compete directly in this category because it does not control the vehicles themselves. It relies entirely on partnerships and software layers. Tesla, meanwhile, owns the hardware stack from phone to car to satellite connection. So would you actually switch to a Tesla-built foldable, or do you prefer Apple's ecosystem? Share your thoughts below. We always read every comment. Q3 of 2026 is being highlighted as the period when Tesla will activate the Pi phone fold production line, and the biggest question now is why Tesla chose this specific quarter. As information about the four-step production process begins to emerge, From the precision die-cast alloy frame to the unboxed module assembly, it becomes clear that Tesla is not only aiming to create another smartphone, but is setting a new standard for durability to compete with Apple. 1. Why does Tesla choose Q3 to launch the PiPhone Fold production line? Tesla chose Q3 2026 to launch the Tesla PiPhone Fold production line because this quarter combines all necessary factors in robotics, components, factory capacity, and financial readiness. After major maintenance at the end of Q2, Tesla's robotic systems reach more than 96% operational stability, which is 3 to 5% higher than the average of other quarters. Error rates drop below 0.3%, allowing the robots to die, cast frames, install hinges, and place circuit boards of the Tesla PiPhone Fold with micrometer-level precision, minimizing defective units from the first batch. Q3 is also the most stable period of the year for the electronics supply chain. Prices for processors, camera sensors, and display panels typically drop 7 to 12% compared to peak quarters, while lead times for components reduce to 9 to 16 weeks. This ensures the Tesla PiPhone Fold has all critical components such as UTG glass, circuit boards, and camera assemblies for continuous assembly, reducing the risk of supply shortages and extra costs. In addition, Tesla factory capacity in Q3 is usually 8 to 15% above actual demand after the early year peak season. This surplus allows Tesla to deploy specialized robotic cells for the PiPhone Fold, performing complex steps such as UTG pressing, circuit board installation, and hinge testing without affecting vehicle production. Utilizing this excess capacity reduces initial production line costs and increases assembly efficiency from the pilot run. Financial factors are also crucial. Tesla's free cash flow typically reaches $2.5 to $3.7 billion at the end of Q2, sufficient to invest in robots, presses, optical inspection systems, and automated testing lines for the Tesla PiPhone Fold. Q3 is the ideal time to implement these investments while maintaining liquidity and preparing for production scaling in the following quarters. Combining all these factors, Q3 2026 becomes the only choice to ensure the Tesla PiPhone Fold production line operates smoothly from the start, minimizes errors, shortens testing time, and produces a durable and stable product. This timing allows Tesla to apply automotive manufacturing philosophy to a foldable phone, creating a superior advantage over current competitors. Do you think Tesla's PiPhone Fold, launching next year, will outperform other smartphones in durability and design? Comment yes if you agree. And if you are curious about how Tesla's first phone will be manufactured, stay tuned for the answer in the next part. 2. How did Tesla use its production line to make the PiPhone Fold innovative, durable, and affordable? Step 1. Build the durable frame and hinge in the precision mechanical area. One of the most notable advantages of the Tesla PiPhone Fold compared to Apple's high-end smartphones is the frame and hinge design. In iPhone Pro models, Apple uses aluminum or stainless steel casing with multiple separate joining parts, assembled manually or semi-automatically. This process creates connection points that can deform under strong impact or drops, with an average assembly error of 0.02 to 0.05 millimeters, increasing the risk of bending or looseness over time. In contrast, the Tesla PiPhone Fold uses robotic mini-gigapress die casting technology to create a seamless frame and hinge. This reduces the number of components from more than 20 in an iPhone to only 5 in the Tesla PiPhone Fold, eliminating most mechanical weak points. Mechanical errors measured in internal testing are approximately 0.003 millimeters, 6 to 10 times lower than high-end iPhone models. The integrated 6K AI camera inspects all details, while robots fold the hinge over 300,000 times to ensure durability before proceeding to the screen assembly step. Furthermore, the monolithic pressing process allows the Tesla PiPhone Fold to withstand impacts or drops better. Simulation tests show that the frame and hinge can endure folding and vibration forces 3 times higher than iPhone Pro models, while reducing the risk of cracking or misalignment after 2 years of use. Automated inspections on the production line detect faults early, lowering the return and warranty rate. Step 2. Install the foldable screen and process the UTG layer in the optical area. The next step in the Tesla Pi Phone Fold production line is assembling the foldable screen module and applying the UTG layer in the optical section. This area is designed based on Tesla car glass processing but scaled down for phone size. The ultra-thin UTG glass is pressed by robots with a protective polymer layer using very low force of approximately 0.5 to 1 Newton, enough to bond without damaging critical fold points. Heat-controlled robots manage the temperature of each area within plus or minus 1 degree Celsius, ensuring even polymer adhesion, reducing creases, and extending screen lifespan by over 30% compared to standard testing. This process is fundamentally different from Apple's iPhone display production. Apple uses flat glass panels and presses Gorilla Glass using semi-automatic thermal systems designed for fixed screens that do not fold. Apple's process focuses on uniformity and scratch resistance, but does not integrate folding mechanics, so the glass is not optimized for continuous motion. Tesla Pi Phone Fold combines ultra-thin UTG, specialized polymer, and fully automated robotic pressing with precise pressure and temperature control at every fold point, allowing the screen to endure more than 150,000 folds without micro cracks or creases. A 6K AI optical camera system then also inspects the entire surface for dead pixels, light leakage, or uneven reflections. Coupled with experience from Model Y impact-resistant glass, this process ensures the Tesla Pi Phone Fold screen is both durable and maintains smooth image quality and touch responsiveness, far surpassing traditional flat smartphone screens like the iPhone. This approach allows the Tesla Pi Phone Fold to achieve exceptional fold durability while maintaining high display performance and user experience, creating a technical advantage over current smartphone competitors. Step 3. Fit the circuit board, battery, and antenna in the temperature-controlled electronics area. The next step in the Tesla Pi Phone Fold production line is installing the circuit board, battery, and antenna module in a temperature-controlled electronics section. Here, Tesla applies automotive production philosophy to the phone, ensuring electronic components are durable and stable during repeated folding and long-term use. The battery is installed into the frame using low pressure of approximately 0.8 to 1.2 newtons to prevent deformation during folding. Internal tests show that the Tesla Pi Phone Fold battery can endure over 200,000 folds with less than 3% capacity loss, demonstrating superior performance compared to standard smartphone batteries. Circuit boards are installed by high-speed pick-and-place robots, handling over 120 components per minute, with a margin of error of only 0.02 millimeters. The vapor chamber heatsink is installed simultaneously and optimized based on AI data from thermal testing of each module, keeping the Tesla Pi Phone Fold below 38 degrees Celsius during heavy usage or repeated folding. The antenna module is automatically calibrated using a signal measurement system similar to how Tesla tests Starlink connections on the Cybertruck, ensuring stable connectivity in all conditions. Compared to Apple's iPhone, where lithium-ion batteries are placed into aluminum or stainless steel shells and circuit boards are installed by pick-and-place robots with only moderate control over pressure and temperature, the Tesla Pi Phone Fold is optimized for folding mechanics. Apple's heat dissipation relies mainly on small metal plates without a full module vapor chamber, and antenna testing is manual or semi-automated without AI integration. Consequently, iPhone batteries and circuit boards are not optimized for foldable mechanics, and their durability under complex mechanical stress is inferior to the Tesla Pi Phone Fold. Step 4. Assemble all modules with the unboxed electronics process and run final tests. The final step in the Tesla Pi Phone Fold production line is assembling the modules using the unboxed electronics process and conducting comprehensive testing. This step represents a major difference from traditional smartphones. Instead of stacking each layer from the bottom up as Apple or other brands do, Tesla assembles fully completed modules, including the frame, UTG screen, battery module, circuit board, and antenna, in a manner similar to unboxed car assembly. The modules are fitted by robots with a precision of only 0.01 millimeters, ensuring a tight fit, durability, and consistency across every device. Immediately after assembly, a 360-degree AI camera system scans the entire phone to detect any structural faults, gaps, or mechanical deviations. The Tesla Pi phone Fold then undergoes extensive mechanical and environmental tests, including thousands of folding cycles, drops from multiple heights, vibration simulations, pressure changes, and temperature variations from -10 to 50 degrees Celsius. Only devices that pass all tests are packaged and shipped. Defective modules return to their respective testing areas for replacement without disassembling the entire phone, unlike traditional smartphone processes where a minor fault can require disassembling the entire device. The Tesla Pi phone Fold is rewriting the rules of what a smartphone can be. Every detail, from the die-cast alloy frame to the foldable UTG screen and precision electronics, reflects Tesla's car-grade engineering applied to a phone. Launching in Q3 2026 ensures flawless robotics, stable supply chains, and optimal factory capacity, giving the Pi phone Fold unmatched durability and performance. Love this innovation? Hit subscribe to help autogearshift reach 20,000, tap the bell, and follow along as we break down every move Tesla makes with the Pi phone Fold. Sit back, we've got plenty more coming.
I do think there's a lot of potential for collaboration with XAI in the future, and with SpaceX.
1. How does SpaceX's Inspired thermal control keep performance steady on long days? Tesla deployed a multi-layer vapor channel paired with phase change panel architecture, compressed into a mobile form factor. We're looking at a targeted heat spread of 8 watts per square inch and a sustained thermal budget of 12 watt-hours before the system even considers throttling. That translates to continuous CPU draw of 6 watts without performance cuts, meaning extended video decode, turn-by-turn navigation, and video calls can run for 6 hours straight without the device choking. Predicted skin surface temperature rise stays under 5 degrees Fahrenheit during heavy loads. The hinge itself is engineered to survive 1 million fold cycles in a lab simulation with less than 0.5% loss in thermal conduction. Those aren't marketing numbers. Those are aerospace-grade durability specs. Here's where Tesla's vertical integration becomes a weapon. SpaceX already manufactures thin vacuum tubes and custom phase change materials at scale for rocket hardware. By sharing that supply chain, Tesla cuts the cost per unit of thermal management by an estimated 20% compared to conventional phone cooling stacks. For seniors using magnified text and GPS navigation daily, this isn't about benchmark bragging rights. It's about consistent, reliable performance and extended device lifespan. Now consider Apple's position. Cupertino's playbook has always been aggressive throttling and conservative clock speeds wrapped in elegant aluminum. But when a foldable device can sustain desktop-class thermals across 2 physical zones, the performance bar shifts permanently. Apple's single-body industrial design cannot distribute heat across hinged surfaces the way Tesla's architecture does. For the first time, a foldable performs like a flagship slab, and that resets every consumer expectation in the category. For seniors depending on telehealth video consultations, real-time medication reminders, or emergency navigation, a thermal slowdown isn't a minor annoyance. It's a failure point that can interrupt critical moments. So here's my question for you. If your phone could run full power for 6 hours without breaking a sweat, what would you actually use it for? Drop thermal control in the comments if this kind of engineering matters to you. 2. How does a foldable phased array antenna inside the hinge offer continuous connectivity? Tesla knows something every American smartphone user has felt at least once. That is why they are taking satellite-level connectivity and shrinking it into a phone. Tesla embedded a 0.9-inch phased antenna strip directly inside the hinge, the one place on a foldable that stays mechanically stable regardless of how you hold it. This isn't passive reception. The antenna actively shapes signal direction, delivering 9 to 14 decibels relative to an isotropic radiator gain, compared to the 2 to 4 decibels relative to an isotropic radiator you get from conventional smartphone antennas. That translates to a 68% improvement in signal holding ability in weak coverage zones. When the Pi phone Fold switches to Starlink relay mode, estimated throughput hits 60 to 120 megabits per second, with latency locked between 40 and 70 milliseconds in hybrid operation. Call drop rates in fringe areas drop by 65%. And because the hinge keeps the antenna away from your hand, you eliminate the grip of death performance loss that plagues iPhones when you hold them tightly during calls. Shared satellite network access and prioritized handoff protocols let the Pi phone Fold negotiate seamless transitions between Starlink, tower, and Wi-Fi, reducing dropped call probability by an estimated 60% in marginal coverage compared to legacy devices. For seniors living in rural Texas or traveling through the Everglades in Florida, this isn't a spec sheet luxury. It's the difference between reaching 911 or staring at no service during an emergency. Apple has carrier partnerships and polished software, but they don't own the satellites, the ground stations, or the relay infrastructure. Tesla controls the entire signal path from orbit to your hand, a vertical integration Apple can't copy without launching rockets. When connectivity becomes a reliability advantage, instead of a marketing bullet point, the competitive gap stops being theoretical. For older Americans covering long distances by car or living where cell towers are sparse, connection reliability isn't convenience. It's peace of mind, knowing help is always one call away. 3. How does an aerospace-grade folding hinge and enclosure offer 5 times durability? Every foldable phone on the market today shares the same fatal flaw. The hinge is a ticking time bomb. Tesla took a hard look at that failure pattern and applied the same stress isolation principles SpaceX uses for rocket components that survive launch vibrations strong enough to liquefy human organs. Tesla built a 2-axis torque balancing assembly with precision bearings and a sealing gasket system engineered to block dust ingress at the micron level. Lab projections show the hinge enduring 1 million to 1,200,000 fold cycles across ambient temperatures ranging from -10 degrees Fahrenheit to 130 degrees Fahrenheit, crushing the industry standard of 200,000 cycles. That's 5x to 6x the durability of anything currently shipping. Drop test protocols target repeated 6-foot falls onto concrete across 4 orientations with less than a 2% increase in hinge play. And because Tesla modularized the hinge and display transfer components, repair labor time drops by an estimated 30% compared to current foldables. Total device weight lands between 8.5 and 10.5 ounces, depending on battery configuration, light enough for all-day carry, heavy enough to feel solid. Apple's design philosophy worships thinness above all else, often at the expense of modular repair. But when a foldable device can outlast a traditional iPhone and cost less to fix, Tesla steals both the durability argument and the lifetime value proposition. That puts direct pressure on Apple's carefully cultivated image as the reliability standard. So, if your phone could survive 1 million folds and still work like new, would you finally trust a foldable? Drop the number 1 million below if you say yes. 4. How does aerospace dual battery layout deliver a 52% longer runtime while providing high capacity? Tesla split the power system into 2 independent batteries, each rated between 9 and 14 watt-hours. Combined capacity lands around 28 watt-hours. That's 52% higher than typical iPhones. But raw capacity is only half the story. Thermal separation between the 2 batteries slows degradation by 22 to 29% over 3 years, meaning the device you buy today will still hold a full charge long after your iPhone starts begging for a charger by noon. An emergency standby module draws under 5 milliwatts, keeping emergency contact functionality alive for up to 72 hours, even when the main battery is completely drained. Safety layers follow the same fault isolation logic as SpaceX battery packs, reducing thermal runaway probability to 0.01%, a fraction of what conventional phone batteries risk. Fast charging hits 50% in approximately 25 minutes at 30 watts, no thermal throttling required. Apple's industrial design religion demands single-stack slim batteries that maximize thinness. But a modular dual-island approach delivers higher usable capacity and longer real-world runtime, and that becomes a persuasive pitch for risk-averse buyers who've been burned by batteries that die after 18 months. What matters most to you in a phone battery? Comment A if you want the longest possible runtime between charges. Comment B if you prioritize battery health that lasts for years without degradation. Comment C if emergency standby power for 72 hours is what gives you real peace of mind. Your answer tells me exactly what you value, and it tells Apple what they're losing. 5. How does integrated emergency and low-orbit assisted location and alerting change user safety and services? Tesla's integrated emergency mode fuses GPS with low Earth orbit timing beacons, cutting time to first fix by up to 40% in urban canyons, where skyscrapers block satellite line of sight. Emergency message bundles stay under 250 bytes to conserve both airtime and power. Assisted location accuracy in degraded environments hits 33 to 98 feet horizontal error, compared to the 98 to 328 feet you get from standard GPS without assistance. The automated emergency handshake attempts up to 4 distinct relays within 15 seconds. The estimated time to alert a central relay and deliver an emergency notification lands between 8 and 25 seconds in assisted mode. Even after a normal shutdown, battery reserve and low-power beaconing keep emergency signaling active for up to 72 hours in a dedicated state, drawing less than 5 milliwatts. Apple offers emergency satellite messaging, but Tesla's tightly integrated low-orbit assisted system with prioritized relays and reserved power budget delivers faster, more reliable, and more persistent emergency signaling. That becomes the decisive differentiator for safety-conscious buyers who refuse to leave survival to chance. For anyone living alone or traveling empty highways through Nevada, Montana, or the Dakotas, quick location tracking isn't convenience. It's the reassurance that when something goes wrong, help knows exactly where to find you. How will Tesla scale? The Pi phone fold production without hitting roadblocks. Tesla's push into consumer electronics with the 2026 Pi phone fold isn't just a smartphone launch. It's a full-scale production engineering challenge. Insider leaks point to 2 main production hubs, a primary facility at Gigafactory Austin, Texas, and a secondary line at Fremont, California. Each facility is projected to handle 120,000 to 150,000 units monthly, translating to roughly 1.4 to 1.8 million units per year from the first year alone. For context, Apple's rumored iPhone Fold is estimated at 900,000 units annually during its initial launch, while Samsung's Galaxy Z Fold 6 manages about 1.2 million. This means Tesla is aiming for the fastest ramp-up among foldable devices in market history. The backbone of this capability lies in the materials and automation strategy. Tesla reportedly employs a hybrid aerospace-grade aluminum alloy for the chassis, combined with carbon fiber composites adapted from Starship prototypes. The result is a hinge system rated for over 500,000 folds and heat resistance up to 110 degrees Celsius, almost double what competitors like Apple or Samsung currently offer, whose flexible screens often max out at 50 to 60 degrees Celsius before degrading. The internal frame is being produced using precision CNC milling machines adapted from Tesla's automotive operations, while carbon fiber reinforcements are applied through automated layup robots, a technique borrowed from high-end EV structural components. Automation continues throughout the assembly line. Tesla plans robotic hinge installation with torque monitoring down to 0.01 Newton meters to ensure uniformity, ultrasonic welding of internal frames, and AI-driven optical inspections at multiple stages. According to leaked engineering notes, this multi-point inspection could cut hinge misalignment and microfracture defects by approximately 40%, which is significant given foldable smartphones' notorious fragility. Even minor hinge deviations in competing models can result in screen creasing, hinge snapping, or uneven folding pressure, issues that plague Samsung and Apple devices despite higher price points. Supply chain management is also a major focus. Flexible OLED panels are reportedly sourced from South Korea, while Tesla experiments with aluminum-ion battery modules produced domestically in Texas. High-performance microprocessors come from TSMC in Taiwan, and minor components, including ultra-thin copper flex circuits, are planned from Japan. Synchronizing these components is complex. A delay in flexible OLED panel delivery could halt the entire line. To mitigate this, Tesla plans a parallel sub-assembly track with buffer stocks capable of sustaining 1 month of production. An uncommon strategy in consumer electronics, but standard in automotive assembly. Vertical integration sets Tesla apart from competitors. Unlike Apple or Samsung, which outsource a majority of foldable phone assembly, Tesla intends to manage roughly 70% of assembly in-house, including hinge fabrication, chassis welding, and module assembly. This allows real-time adjustments to production protocols, quality checks, and material handling based on daily output, reducing defect rates and shortening the time from assembly to shipment. Analysts estimate this could accelerate Tesla's time to market by up to 3 months compared to Apple, while maintaining production volumes higher than Samsung in the early stages. Finally, energy efficiency and sustainability are embedded in the line design. Tesla reportedly uses regenerative assembly robots that recapture kinetic energy during hinge installation and modular subassembly, reducing power consumption by an estimated 15 to 20% per unit compared to traditional assembly lines. Coupled with low-waste materials and automated recycling of defective panels, Tesla aims for both high throughput and environmentally conscious production, aligning with its broader EV manufacturing ethos. Which part of Tesla's PiPhone Fold production impresses you the most? The robotic assembly, materials, or supply chain integration? Comment A for robot, B for materials, or C for supply if you think that's the coolest part. Then, share why in the comments below. What battery technology powers the Tesla PiPhone Fold, and how does it compare? One of the most critical aspects of the 2026 Tesla PiPhone Fold is its battery system. According to multiple leaks from suppliers and insiders, Tesla is moving away from conventional lithium-ion chemistry, instead opting for aluminum-ion, Al-ion modules. These batteries reportedly allow for full charge cycles in roughly 9 to 12 minutes, compared to Samsung Galaxy Z Fold 6's lithium polymer battery, which takes about 70 to 75 minutes for a full charge, and Apple's expected iPhone Fold at 65 to 70 minutes. While these numbers are based on lab projections, insiders suggest that even accounting for real-world inefficiencies, Tesla could deliver 40 to 50% faster charging than competitors. Capacity-wise, the Al-ion pack is estimated at 1,100 to 1,200 mAh per foldable module, with 2 modules integrated for the full device, giving a total effective capacity of approximately 2,200 to 2,400 mAh. Thanks to Tesla's proprietary energy-dense electrode design, this is expected to maintain up to 90% capacity after 1,500 full cycles, outperforming standard lithium-ion batteries in both lifespan and thermal stability. By comparison, Samsung's foldable models typically degrade to 80% capacity after 800 to 1,000 cycles, and Apple's new foldable design is projected to last around 900 cycles. Thermal management is another key advantage. The PiPhone Fold allegedly incorporates a micro heat dissipation system, derived from Tesla EV cooling tech, including graphene-coated heat spreaders and microfluidic cooling channels. This allows the device to operate under heavy usage, gaming, video streaming, or multitasking with vehicle integration, without throttling. Competitors like the Galaxy Z Fold or iPhone Fold still rely on passive cooling, which can lead to significant thermal throttling under prolonged load, limiting performance in real-world scenarios. Efficiency doesn't stop at raw charge speed. Tesla reportedly integrates vehicle-to-phone (V2P) and phone-to-vehicle (P2V) charging protocols, meaning the Pi phone Fold could theoretically draw power directly from a Tesla EV battery in emergency situations, potentially adding 50% charge in under 10 minutes. This aligns with Tesla's vision of a fully integrated ecosystem, giving the phone an edge Apple and Samsung cannot currently match. Finally, energy density and weight balance play a role in user experience. While Li-ion batteries are slightly heavier than lithium polymer units, Tesla's chassis design offsets the additional 15 to 20 grams by redistributing mass along the hinge and internal frame. The result is a device that feels balanced in hand and resists accidental bending or creasing, a subtle but important advantage over competitors, whose foldables often feel top-heavy or unevenly weighted. How Tesla could deliver a $219 Pi phone Fold without compromising core features. While most foldables today command $1,200 to $1,900, Tesla could realistically target a $219 retail price for the Pi phone Fold and still maintain a reliable functional device. The secret is vertical integration, scale, and smart material selection. By producing the foldable OLED panels in-house or through its EV supplier network, Tesla can cut component costs significantly. Estimates suggest that producing OLED panels internally could save $40 to $50 per unit, compared to purchasing them at standard consumer electronics rates. Hinge design is another major cost driver. Instead of expensive aerospace-grade carbon fiber, Tesla could use aluminum alloy with precise CNC machining, balancing durability with affordability. The hinge could still be rated for 200,000 to 250,000 folds, sufficient for the average user's lifespan of the device, but at a fraction of the cost of premium hinges in Samsung or Apple foldables. Combined with automated robotic assembly, the production cost per unit could realistically fall to $100 to $120, leaving room for a $219 MSRP while maintaining standard retail margins. Battery and electronics also support cost efficiency. The Pi phone Fold's aluminum-ion modules are smaller, cheaper to manufacture, and faster to charge than high-capacity lithium-ion packs found in competitor foldables. While a Samsung or Apple foldable uses lithium polymer packs costing roughly $50 to $60 per unit, Tesla's Li-ion solution may cost $25 to $30 per unit. Despite the smaller size, the modules can deliver rapid charging in under 12 minutes, with stable thermal performance thanks to micro heat dissipation channels derived from EV battery technology. In 2026, a new era of smartphones is emerging, and this time it's all about foldable phones. As experts put it,
I mean, everybody wants as big a screen as possible, but you don't want this big bulky thing in your pocket.
That's exactly why foldable phones are gaining traction, offering larger displays without the size compromise.
That's a big thing. It's interesting.
Elon Musk has soon recognized the potential and stepped into the foldable phone game. 1. How does Tesla redefine the definition of fold in a way that Apple cannot believe? Tesla doesn't treat the Fold as a simple hinge. They approach it like a structural problem, using the same method SpaceX applies to metallic surfaces under rocket stress. The result is a folding system unlike anything Samsung, Motorola, or any Asian supplier has built. So how can this fold actually transform daily use for seniors instead of being just another flashy novelty? Instead of resisting stress at one narrow line, Tesla reimagines how stress travels across the entire folding region. Early supply chain reports confirm the Pi phone Fold deploys a multi-layer composite ridge, where each layer carries a distinct elasticity profile. Every fold and unfold distributes the load across a zone nearly 4 times wider than current foldables, which compresses everything into a thin 0.04-inch to 0.08-inch band. Tesla spreads the punishment smoothly instead of crushing it into one fragile point. Apple's rigid spine architecture makes this approach impossible without gutting its entire display and chassis system from the ground up. The practical shock factor hits hard for Americans using their phones relentlessly throughout the day. Traditional foldables develop deep creases because that same narrow strip absorbs the full force on every single open and close. Tesla's load distribution slashes crease progression by 47% across 12 months of high-frequency use, according to early simulation data from industry engineers. For seniors, this translates to opening the device dozens of times daily without fearing the center will weaken, deepen, or fracture. Tesla injects another disruptive element: micromechanical damping embedded directly into the flexible substrate, not tucked inside the hinge. Instead of depending on hinge tensioners, the fold region itself absorbs and releases movement energy. The folding motion feels disturbingly smooth and uniform, like turning a page in a hardcover book rather than bending an electronic display. Apple cannot adopt this because it violates its core design philosophy that moving parts stay isolated inside mechanical assemblies, never blended into the display body. Thanks to that, Tesla offers a foldable phone that behaves like a dynamic surface rather than a joint. Early prototype testers describe it as folding without feeling the fold. No click, no abrupt resistance shift, no sensation of mechanical parts engaging. The entire frame flexes as one continuous piece rather than a rigid phone forced to bend. This is why Apple cannot believe Tesla's solution. It overturns the fundamental mechanical logic behind every foldable released over the past decade. Tesla's approach mirrors aerospace-grade surface engineering more than consumer electronics, transforming the fold into an active structural zone instead of a vulnerable mechanical line. Have you ever hesitated on foldables because of durability concerns? And does Tesla's stress distribution engineering finally make you willing to switch? Let's take a quick answer by dropping "fold" in the comments if this approach changes your entire perspective on what foldable reliability should actually mean. 2. How does PiPhone Fold quantum-secure fabric outstrip iPhone 17 encryption? Tesla PiPhone Fold deploys lattice-based cryptography at 512 qubit equivalents, a defense architecture engineered to withstand quantum attacks already being tested in California data centers. Meanwhile, iPhone 17's AES-256 encryption faces a 38% vulnerability rate in projected 2030 simulations specifically targeting senior financial apps. The gap is actually a countdown to when current encryption methods collapse under quantum computing pressure. Here's the brutal cost reality. PiPhone Fold integrates future-proof security protocols in 32 simple steps at zero extra cost for full 512-qubit protection. This eliminates the need for scam block apps that cost seniors an average of $250 annually for banking protection, which are the expenses iPhone 17 users absorb while relying on basic 256-bit infrastructure that requires $180,000 in total industry fixes just to patch vulnerabilities as they emerge. The financial breakdown gets more aggressive. Basic quantum protection comes standard with no upgrade fees. Optional key updates run $120 if users want enhanced customization. Compare that to iPhone 17's security ecosystem. Average add-on fees hit $1,300, plus devices suffer a 1.3% depreciation in resale value due to outdated encryption standards. Over a lifetime, PiPhone Fold users save approximately $6,000 by treating quantum resistance as foundational infrastructure rather than premium features bolted on later. Tesla collaborates with trusted cryptographic consortiums to generate longer-lasting keys using reinforced grid patterns that eliminate the 1.4% transaction fee rates many financial apps impose for additional security layers. This puts roughly $900 back in users' pockets annually, just from avoiding redundant protection costs. Pi's threat detection system processes 1,000 trillion possible attack vectors with every authentication cycle, which is 28% more comprehensive than iPhone 17's fixed scanning protocols that rely on known threat signatures instead of adaptive modeling. The integration factor separates competent engineering from revolutionary design. Tesla embeds quantum key distribution modules directly into the Fold's edge architecture, enabling seamless credential switching as the device opens and closes. This reduces dropped connections during secure sessions by 22% in movement tests, compared to the iPhone's slower credential handovers that require full reauthentication. Power efficiency remains brutal. Pi's security operations add just 0.8% battery drain during active protection cycles versus iPhone 17's 1.5% background consumption for comparable threat monitoring. Error correction becomes critical in real-world chaos. Pi Phone Fold includes quantum error correction codes operating at 99.7% accuracy, outperforming the iPhone 17 by 15% in noisy environments like Texas construction sites or crowded subway stations where signal interference spikes. Key longevity projections estimate 12 years of cryptographic validity, 40% longer than iPhone 17's 8-year security ceiling, saving users an estimated $400 in forced security update cycles. Traditional encryption leaves personal information exposed during online transactions, especially for those on fixed incomes who can't afford recovery from financial breaches. Pi Phone Fold's quantum fabric builds impenetrable barriers, restoring confidence for users who depend on digital banking, but fear becoming the next fraud statistic. The security gap between these devices isn't about features. It's about whether your financial identity remains yours or becomes collateral damage in the quantum computing era. But unbreakable security means nothing if the device can't keep pace with how seniors actually work and communicate throughout their day. Don't skip away to see how Tesla gives you a phone that elevates both of these criteria. 3. How does Tesla Pi Phone Fold unlock hidden productivity and connectivity for seniors? Pi Phone Fold deploys a layered connectivity stack that automatically prioritizes Wi-Fi, then cellular, then satellite or local device mesh without requiring manual intervention. This architecture dramatically reduces dropped calls and failed messages during storms or in poor signal areas. In unstable conditions where iPhone 17 calls or messages fail 40% to 60% of the time. Pi Fold empirically maintains critical communications approximately 90% of the time. That gap isn't marginal. Instead, it's the difference between reaching emergency services or family during a crisis versus staring at a failed connection screen. The Fold state-driven interface maps precise fold angles to practical modes that adapt in real time. Partially folded, it automatically opens large, simplified buttons for one-tap calls. Folded to a compact position, it prioritizes messaging with enlarged text and a single send button. Early testing reveals approximately 25% faster workflow completion for users 65 and older, with significantly fewer mistaps. iPhone 17's rigid interface can't adapt to posture or simplify itself automatically. That's why users get the same cramped layout regardless of how they're holding the device or what task they're attempting. On-device alert filtering ensures only high-priority messages, including health reminders, verified contacts, emergency alerts. Pi Phone reach the user, reducing irrelevant notifications by up to 70%. Combined with connectivity fallback and adaptive media flow, video calls or health monitoring sessions on Pi Fold remain stable approximately 85% of the time under mixed network conditions. iPhone 17 under identical conditions succeeds only about 55% of the time, forcing users to restart calls or abandon appointments entirely. Ergonomics and accessibility receive surgical attention. Tactile large buttons, amplified haptics, and optimized antenna patterns designed for common household postures. This combination reduces errors, prevents frustration, and saves time, making productivity and connectivity predictable rather than stressful. Seniors drastically reduce accidental wrong number callbacks, a persistent problem on iPhone 17 caused by small text and convoluted menus that punish users for minor finger placement errors. So, does PiPhone Fold's adaptive interface finally solve your usability crisis older users face daily? Let's drop unlock in the comments if you believe technology should adjust to people instead of forcing people to adjust to rigid designs that ignore how they actually live.
It's going to be crazy. That's why I say, like you say, what's the future going to be? It's not going to be a conventional phone.
And he's not wrong. This phone is designed to support your life without frustration.
Which will hopefully release in a few months, and then it's also integrated into the X system.
The X phone.
1. How practical is free Starlink structured? Tesla's idea of offering free Starlink for life with the PiPhone sounds impossible at first. Americans hear the word free and immediately think, there's a catch. But here's the part that matters. Start with device subsidy mechanics. Tesla subsidizes the phone up front, let's say $200, and spreads that cost across a 5-year window. That's $3.33 per month in amortization per user. Now here's where the revenue offset kicks in. Device margin on accessories, in-app transaction fees, and optional premium tiers like priority bandwidth or encrypted privacy packages. If just 20% of users spend $5 to $10 per month on those add-ons, the subsidy cost gets absorbed entirely. You're not paying for Starlink directly. You're funding it through ecosystem participation. Tesla doesn't lose money. You don't pay monthly bills. The model balances. Next is guaranteed lifetime terminal allocation. The PiPhone could ship with a hardware-locked Starlink eSIM token, containing a pre-funded service credit pool tied permanently to that device. SpaceX backs this with a carrier-grade contract guaranteeing connectivity credit redeemable only through that hardware. Think of it like Tesla bulk purchasing massive blocks of monthly access at wholesale scale, then embedding that credit directly into your phone at the manufacturing level. For users, billing complexity vanishes. For SpaceX, fraud risk disappears because the credit is hardware-bound and non-transferable. But here's the critical distinction. Free Starlink doesn't mean unlimited 4K streaming from a mountaintop. It means emergency connectivity and low-bandwidth essential services, including emergency voice and SMS over satellite, prioritized push alerts, location tracking, and low-data health telemetry for telemedicine check-ins. That trimmed service model reduces capacity cost from hundreds of dollars per year down to a marginal per-user expense in the $10 to $60 range annually, depending on usage caps and subsidies. SpaceX preserves critical value for users while keeping infrastructure costs sustainable. Now let's talk operational feasibility. Over the past year, Starlink expanded to 42 new countries and territories while adding 2.7 million active customers globally, now serving more than 6 million people with high-speed, low-latency internet. During that same period, SpaceX launched more than 100 Starlink missions, deploying 2,300 satellites and investing heavily in ground infrastructure, network backbone, and internal systems. Typical Starlink residential plans run $40 per month for basic service. Bundling emergency-only access or a heavily subsidized plan drops the effective per-user annual cost dramatically. Market dynamics make targeted lifetime offers not just plausible, but strategically viable if scoped to emergency and low-data needs. Doesn't it feel liberating to think of a device that keeps you linked, giving you that peace of mind you've always wanted? No carrier contracts, no roaming fees, no dead zones where your phone becomes a paperweight, just persistent global connectivity when it matters most. So, if your phone could reach a satellite constellation anywhere on Earth without a monthly bill, would you ever go back to a carrier plan? Take a quick action by dropping free Starlink in the comments if this changes how you see mobile connectivity in 2026. 2. How do aluminum-ion batteries transform durability in everyday use? Let's start with thermal stability. Aluminum-ion tech in the PiPhone Fold withstands temperatures up to 140 degrees Fahrenheit without degradation. Lithium-ion taps out at 122 degrees Fahrenheit. That 18-degree buffer matters when you're living through Texas summers, where ambient heat regularly pushes past 100 degrees Fahrenheit and your phone sits on a car dashboard. Lithium batteries swell, degrade, and in worst cases, ignite under sustained heat stress. Aluminum-ion eliminates that fire risk entirely. Your phone doesn't become a thermal liability in extreme conditions. Now look at the anode architecture. The battery uses aluminum foil layered with graphene composites, pushing cycle life to 5,000 charges. Compare that to the 1,200 to 1,500 cycles you get from current iPhones. That's 3 to 4 times the longevity, translating to 8 to 10 years of daily use before capacity drops meaningfully. You're not replacing this device every 2 years because the battery can't hold a charge anymore. You're keeping it through an entire decade of use. For users in humid Florida, corrosion resistance becomes critical. Aluminum ions sealed electrolyte prevents moisture ingress, cutting failure rates by 40% to 50% in high humidity environments over 80% relative humidity, based on controlled lab simulations. Lithium-ion batteries exposed to prolonged humidity develop internal corrosion that accelerates capacity loss and connectivity failures. Aluminum-ion construction solves that problem at the chemistry level, not with external coatings that eventually wear down. Energy density hits 500 watt-hours per kilogram, running 20% to 30% higher than lithium's 300 to 400 watt-hours per kilogram range. That density advantage allows slimmer designs at 0.2 inches thick, perfect for foldables that actually fit in pockets without bulk. For users over 65 dealing with arthritic hands, device weight and thickness aren't cosmetic concerns. They're usability barriers. A lighter, thinner phone with equivalent or better battery life directly addresses those complaints without compromise. Integration with Tesla's recycling loop adds another dimension. The battery's aluminum is 95% recyclable, aligning with California's zero-waste initiatives and potentially saving 10 to 15 pounds of electronic waste per user over a decade. You're not just buying a phone, you're participating in a closed-loop manufacturing system where end-of-life materials feed back into new production runs. That's not greenwashing, that's operational circularity at scale. While lithium-ion suffers from dendrite formation after 2 to 3 years, leading to 20% capacity loss, aluminum-ion solid-state interface minimizes degradation to under 5%. That means consistent performance across long-haul drives spanning 800 miles of Texas highways, where your phone stays reliable as a navigation tool, communication device, and emergency link without anxiety about sudden shutdowns. The battery doesn't degrade into unpredictability. It maintains baseline performance across years of hard use. And early PiPhone prototypes show vibration tolerance up to 10 gravity forces, surviving a 4-foot drop with 2 to 3 times better resilience than standard phones, backed by drop test data from similar materials used in aerospace applications. You're not babying this device with bulky cases because the screen might shatter. The internal structure absorbs impact forces that would crack conventional smartphones. 3. How can XOS be a true operating system shift? The foundation starts with a hardware-enforced emergency stack. Instead of depending on the main interface, XOS would keep a sealed, minimal runtime that can independently activate Starlink, push location data, and place emergency calls, even if the phone is frozen or the battery is critically low. This layer would run through a verified boot chain tied to a hardware root of trust, reducing failure modes that often put seniors at risk during blackouts or after car accidents. It is not showy, but it is the kind of engineering that saves lives. The second piece is phishing resistance at the operating system level. XOS could analyze money transfer screens and credential prompts at the system layer, not inside individual apps. If a caller ID cannot be verified or a link triggers risk signals, the system would halt the transaction and force a trusted contact approval step. That level of intervention is something app-level warnings cannot deliver, and it directly addresses the rising number of scam attempts targeting older Americans every year. Then comes simplicity. Instead of burying basic tools inside layers of apps, XOS could offer a genuine task-first interface.